We're constantly hearing about these incredible things AI can do, right? Writing code, creating unbelievable art. But the real magic, the thing that makes every single machine learning model tick, actually starts with something way less glamorous, but way more important: getting the data ready. So let's dive into this secret world of data preprocessing. I love this quote because it absolutely hits the nail on the head. Raw data on its own is full of potential, for sure, but it's also usually a total mess. It's inconsistent, it's got gaps. So data preprocessing, that's the craft. It's about taking that messy raw material and turning it into something clean, structured, and, well, brilliant. Something that's ready to power our algorithms. All right, so before we can start polishing our data diamond, we need to know how we even hold it in the first place. In the world of Python, the go-to library for this is called NumPy, and it gives us two key structures to work with. First step, you've got the vector. It's the simplest structure, really. It's just a single line of numbers. So think of it as one single observation in your data. Like for one passenger on the Titanic, a vector could hold their age, their ticket class, and whether or not they survived. Simple as that. So, how do we go from just one passenger to the whole ship? Easy. We just stack all those individual vectors together. And what you get is a matrix, this two-dimensional grid. And that is the format for machine learning. Every row is an observation, like a passenger, and every column is a feature, like their age or fare. It's what our models expect to see. So we've got our containers, our vectors, and matrices. Now comes the fun part, the great cleanup. And for this job, we're going to bring in the data wrangler's best friend, an amazing library called Pandas. Let's work with a real-world classic example, the passenger list from the Titanic. Now, you look at this table, and at first glance, it seems pretty organized, doesn't it? You've got names, passenger class, age, but trust me, looks can be deceiving. There are all sorts of problems lurking just under the surface that we have to fix. And this is what we're really up against. In the actual Titanic data, a whole bunch of passengers don't have an age listed. Bam, missing values. The passenger class, P class, it's stored as text, like first or second, which a model can't really compute. Then you've got two different columns for gender, sex, and sex code, which is just redundant. And as we're about to see, there are even straight-up errors. So here's our game plan for the cleanup. First, we'll select only the data we actually need. Then we'll tackle all those missing or broken values. And finally, we'll transform our features into a language that a machine learning model can actually understand. Okay, let's make this really concrete. Say you're digging into that passenger class column, P class, and you find something weird, a single asterisk. It's not first class, not second, not third. So what is it? And what on earth are we supposed to do with it? Well, the first thing you do is you go hunting for these oddities. With just one simple command, we can count every unique value in that column. And look what it spits out. You see the counts for third, first, and second class, and then, there it is, one single entry, that weird asterisk. Finding these little mistakes is such a critical part of the cleanup job. Once we've found an error like this, we've got a few options. We could try to replace the asterisk with the right value, if we can figure it out. Or, since it's just one row out of hundreds, we might just decide to drop it completely, to protect the quality of the rest of the data. The goal, always, is consistency. Okay, deep breath. Our data is now clean, it's consistent, but we're not quite done yet. It's still not ready for a model. Now comes the final step, the machine learning makeover. This is where we give it that final polish. See, a lot of algorithms get confused if your numbers are on wildly different scales. Like age might be from 0 to 80, but the ticket fare could be in the hundreds. So we need to get them on the same page. On one hand, you can do what's called rescaling, which squishes everything into a set range, usually 0 to 1. This is super common for neural networks. On the other hand, you can standardize the data. This changes it so the average is 0 and the standard deviation is 1. It's a really safe, robust bet and often a great place to start. So that's great for our numbers like age. But what about all the text? The categories? A machine learning model has no idea what female or first class means. How do we turn that text into numbers without totally confusing the algorithm? Now, you can't just say first class is 1, second is 2, and third is 3. If you do that, the model might literally think that third class is 3 times more valuable than first class, which is just nonsense. The solution is this really clever trick called one-hot encoding. What it does is create a brand new column for each category with just a 0 or a 1. And here's exactly what that looks like. Our original P-class column vanishes. In its place, we get 3 new columns. So if a passenger was in first class, they get a 1 in the P-class_1 column and a 0 in the other 2. See? This lets the model understand the category without making any wacky assumptions about numerical order. It's pretty genius. So as we wrap this up, it starts to become really clear that all this stuff, the cleaning, the transforming, the encoding, it isn't just boring busy work. It is the silent, unsung hero of the entire AI process. Get this. People have said for years that data scientists spend up to 80% of their time on the job not building cool algorithms, but doing exactly what we just walked through. All that wrangling and cleaning and preparing, that's where most of the work really happens. And that brings us to the biggest takeaway of all. You can have the most powerful, most sophisticated algorithm in the world, but if you feed it garbage data, you're going to get garbage results. The quality of your input dictates everything. Clean, prepared data, that's the real hero of the story. So I'm going to leave you with this thought. The next time you see some big headline about a revolutionary new AI, maybe the first question you should ask isn't, wow, how does the code work? But instead, I wonder what kind of pristine, beautiful data made that all possible.